Good day. Thanks for joining me. This is the Adobe Fikemba. Okay. So in this session, I'm going to teach you physics, chemistry, biology. And this is going to be the last subject for the day. So I'd like you to follow me. So we've learned biology, we've learned chemistry. Now we're going to be learning physics. So quickly in physics, go and watch my physics part 1, part 2, part 3, part 4, as the case may be. We have been looking at measurement and units. Now today, we are going to be looking at the measurement of mass in physics. So follow me. I'd like you to follow me. Follow me. We're going to be looking at the measurement of what? Mass. Now quickly, let me just clean this part for the sake of measurement, physics. We're going to be looking at measurement of physics. So we're looking at physics. So measurement of mass. So what is mass? What is mass? Mass is defined as the amount of matter it contains. That's what mass is. The amount of matter it contains. So if I bring this material now, all the thing found inside this is the mass of the whole of this material. It also means a measure. Okay, mass also means a measure of the body inertia. So number one, I say mass simply means the amount of what matter it contains. Amount of matter it contains. Number two, it is also a measure, a measure of the body, what? Inertia. Is a measure of the body inertia. What is matter? Matter is anything that has mass, not weight. Mass and occupies space. And what is inertia? That is its resistance. Okay? Its resistance in motion. Okay? A body's resistance in motion. That's what inertia is talking about here. So it's a measure of the body inertia. And number three, another thing again, I'm just atomizing it so that it will be very easy for you to understand and all that. I want you to also know that mass is what? Oh, my marker. Mass is what? Mass is different. Mass is different from weight. From weight. So I've told you that mass is the amount of matter it contains. Is a measure also, is defined also as the measure of the body inertia. Inertia here is the resistance of the body in motion. Okay. And matter is anything that has mass and occupies space. And I also said mass is different from weight. You have to know that. This is the amount it contains. Weight is a measure of the attraction of the earth of a given mass. So weight is a measure of the attraction of the earth of a given mass. That's why you see weight's formula will be W equals to mg. Can you see that now? What this means is that equal masses in the same location in a gravitational field will be equal to their weights. They will have equal weights. I take it again. This statement simply means that equal masses in the same location in a gravitational field will have equal weight. Take note of that. So mass is different from weight, which is a measure of the what? Of the attraction of the earth of a given mass. Okay, now with this now, having given you the relationship between mass and weight, we are going to quickly look at the differences between this mass and weight. I'm just trying to be fast so that I can be able to wrap today's training up. Are you with me? That's what I'm trying to do. Okay? Just wrap it up. Now, so let's look at this now. I'm going to tabularize this now. Just follow me. The differences. I'm sorry, my marker is failing. Okay? You can say I've been using it to teach all the various subjects. But help me to just listen carefully. The differences between mass. So here, let's write mass. Okay? And here, let's write weight. Okay? Now, what is the difference between mass and weight? Number one is that mass is a scalar quantity. So I'll just write scalar here. What is scalar? Something that has to do with size. Okay? Size. Magnitude. Okay? Scalar has magnitude. Okay? Now, weight is a vector quantity. Weight is a vector quantity, meaning it has magnitude and direction. Number two, mass is always constant. Okay? Mass is always constant. The weight varies from place to place. Number two, weight varies from where? Place to place. Number three, What is the SI unit of mass? System International of Mass is what? Kilogram. So I'll just write it as kg. Okay, follow me. What is the SI unit of weight? The SI unit of weight is what? Newton. The SI unit of weight is what? Newton. Let me break it down. It's the same thing as kilogram meter per second square. Can you see that now? Take note of this. When we talk about equivalent units, we're going to be using this to analyze when we get to that place. Number 4, what else can you see that we can use to differentiate mass? The instruments that are used in measuring mass example include what? Lever balance. Lever balance, because the marker is finished, just follow me. We have lever balance, we have top pan scale, we have chemical balance, we have beam balance. Oh, I need to write this in so that those of you writing, we have beam balance. Beam balance is BEAM. Lever balance is LEVER. You can spell balance. Balance is BALANCE. Okay, we have top pan scale, TOPPAN, then scale, SCALE. Okay, these balances are used to measure mass. Okay, why the instrument used to measure weight is called spring balance. Are you seeing it now? Spring balance. SPRING. Spring balance is used to measure weight. Number 5, another thing again you can use to differentiate between mass and weight is that these balances or this instrument used in measuring mass, they work on the principle. Why this one will work on the principle of moment. Moment, M-O-M-E-N-T. Okay, the product of force and times its direction. That's the product of force and distance rather for moment. Now, weight. The instrument which is spring balance will work on what? It works on the principle of what? Hooke's law. So this one works on the principle of Hooke's law, which is for weight, which is the spring balance. Why this chemical balance, top pan scale and all that, they work on the principle of moment. With this, you've been able to differentiate between what? Between the mass and the vector. Let me quickly run down because I want to end that. Then we'll talk about fundamental units, fundamental quantity, derived unit as the case may be. Let's look at quickly measurement of what? Time. Measurement of time. Measurement of time. Quickly. What is time in the first place? So what is time? In the first place, what is time? Time is the interval between two physical events. Time is the interval between what? Two physical events. Is that clear? And the SI unit of time is what? Seconds. The SI unit of time is what? Seconds. The SI unit of time is seconds. Now, the next thing I want to ask you now is, what is seconds? What is seconds? I told you that time itself is the interval, okay? The interval between two physical events. You can say that interval is the differences of occurrence between two physical events. And this time is measured with what? The SI unit is what? Seconds. What is seconds? Are you with me? What is seconds? Okay. I said seconds is the time interval occupied, okay, in 9,192,631,770 cycles of energy changes in a calcium atom. Of what? Energy changes in a what? In a calcium atom. So this is the definition of seconds. Okay, it is the time interval occupied in 9,192,631,770 cycles of energy changes in a calcium atom. That is the definition of seconds. Is that clear? Now, I want you to know something, that these seconds, or this time, rather, can be measured using certain instruments, such as, number 1, we have what we call stop clock. 2, we have stopwatch. Okay? Stopwatch. Number 3, we also have the human pulse. Number 3, we have the what? Human pulse. Are you with me? Number 4, we have simple pendulum. Simple pendula. And number 5, we have ticker timer. Now, I want you to take note of something. All these instruments used in what? In measuring time, they are what? They work on the principle of what? They work on the principle of simple harmonic. Principle of simple harmonic what? Motion. Is that taken? So they work on the principle of simple harmonic motion. Thank you for joining me. And I'd like you to follow me if you have not been following me. Okay, so that you can see more videos that will build your science world. Okay, if you're going to write JAM, you're going to write WAEC and all that, this will prepare you. I'm ready by the grace of God to build you up. So follow me and share the video. Thank you. See you in the next video where we'll be dissecting various subtopics as the case may be in the subject. Thank you.